At 741 torr and 44 degrees Celsius, 7.10 grams of a gas occupies 5.40 liters. What is the molar mass of the gas? So what kind of information do we have here? 741 torr is a measure of, hold on one second here. Oh, there we go. 741 torr is a measure of pressure. Hopefully you remember that torr is a unit of pressure. So 741 torr is our unit of pressure. 44 degrees Celsius is a unit of temperature. 7.10 grams is an amount. And 5.40 liters is a measure of volume. So we have a P, a T, and a V. It looks also like we have an amount, right? We have 7.10 grams. However, we are unable to convert those grams into moles because we don't know the identity of the gas. In order to convert into moles, you have to know what elements comprise the gas. We're not given any clue as to what this gas is made up of. So we have a P, a T, and a V. We have no change in any variable. We don't have a P1, a P2. We don't have a T1, a T2, or a V1 or a V2. Right? So we must be using the ideal gas law. PV equals nRT. Again, we know P, we know V, we know T. R is a constant, so we know that. What can we solve for? Well, it looks like we can solve for the number of moles. Right? Since we couldn't convert this grams here into moles, we can solve for the number of moles. Let's go ahead and solve for N. So in the ideal gas equation, if we're solving for N, we get PV divided by RT equals N. Okay, so let's go ahead and put some numbers in here. We have a P of 741 torr. We have a V of 5.40 liters. Okay. We have a T of 44 degrees Celsius, but remember that R is always going to be in Kelvin, so we need to convert our degrees Celsius into Kelvin. That is going to be our 44 plus 273 should give us a T of 317 K. So let's put this down here, 317K. And then we just need an R. We're going to look up R on a table. Remember that we're looking for an R that matches our units of pressure. Our units of pressure in this case are torr, so we're looking for an R that has units of torr. If we look this up on a table, we will see that R should be 62.364, and that is liters torr divided by mole Kelvin. So this means that our liters are going to cancel, our torrs are going to cancel, and our Kelvin will cancel, giving us an answer in moles, which is what we're looking for. We're solving for N, so we want an answer in moles. So if we put this into our calculator, we have 741 times 5.40, and then we're going to divide that by 317 times 62.364. We should get a number of moles of 0.202 moles. Okay, now the question is asking for the molar mass of the gas. Molar mass is measured in grams per mole. We have moles. We were given grams in the problem. So we can determine the molar mass by taking the grams of our gas, 7.10 grams, and dividing it by its number of moles. So 7.10 divided by 0.202 tells us that our gas has a molar mass of 35.14 grams per mole.